Thanks, Brian. I'd like to start by acknowledging my co-author, Chris Bodine with Texas Parks and Wildlife. He actually did all the sampling work that I'll be presenting here today. Also want to thank a bunch of people that helped us. Our home agencies, I'm at Oklahoma State, Chris with Texas Parks and Wildlife. A lot of undergraduates that came out and helped us in the boat from Oklahoma State. A lot of ODWC, Oklahoma Department of Wildlife Conservation biologists and technicians helped with this project. And it was funded by a sport fish restoration grant, which ODWC handled the pass-through, and our Cooperative Fish and Wildlife Research Unit administered that account. So when we're making management decisions, a lot of times the quality of that management decision is going to be contingent upon the quality of the sample that we draw. So a lot of research focuses primarily on two aspects of data quality: accuracy, which is how true your sample represents the real thing you're sampling, and precision, which is how reproducible or how much variation is there in the measurement that you take relative to the full population. Another important consideration, though, is efficiency. And what I mean by that is, can I get a reasonable sample with a reasonable effort? In the literature, you'll often see this expressed as the number of fish per day or number of fish per person hour of effort that had to be expended to get the data. And it really gets at, what is the cost, time and money, to me if I'm going to go and collect a full sample using this gear. So it doesn't do us a lot of good to have a really accurate and precise gear if it's so onerous to use it that we don't have time to deploy it very often. So because of that, we do need research looking at ways to make our sampling more efficient. Now, we never want to sacrifice our accuracy or our precision, but where we can refine the methodology to save some time, that allows us then to focus additional replicates or other systems that wouldn't have had time to be sampled, or to just work on other management activities. So let's focus in and talk about sampling of blue catfish. Zach and I probably should have gotten together. You're going to see a lot of the same review here. What we know about sampling blue catfish is you can get them with a lot of different gears. Most gears have pretty low catch rates. The one exception to that is low-frequency electrofishing. And the telephone magneto generator is kind of where this all started. It really wasn't until about the 1980s that we had professional grade equipment that was designed to target that low frequency response. And really even from the 80s forward, there's very little research looking at the quality of this gear until we get into about the last 15 years. So let me quickly summarize what we do know about blue catfish low frequency electrofishing. So the first thing that you'll see in the literature is that catch per unit effort is a pretty accurate index of abundance, as long as you're sampling at those warmer water temperatures, and the recommendation in the literature is to stay above about 18 degrees Celsius. For fish between 250 and 1,000 millimeters long, which is a pretty good range in there, there's no size bias for this gear, so it's very accurate at getting length frequency data if you stay within those bounds. And then the literature recommends that we do at least 20 replicate sites. The reason for this is that these fish, we've found, tend to school by size class. So you may get a lot of fish in one or two samples, but that does not adequately describe the size structure of your population until you get adequate spatial coverage, and it often takes roughly 20 samples to do that. And when you've taken 20 samples, your relative standard error, which is the way we typically measure precision, is usually quite good, usually below 20. And as I've mentioned, this is the gear that has the most fish coming up for the effort that you do, so it appears to be the most efficient gear. But that's not to say that we don't have efficiency problems here. It actually is one of the more costly methods to collect fish that I know of. All of the literature that gave rise to the stuff on the top half of the slide here used a shock boat and 2 chase boats, either with 1 or 2 dip netters on the chase boats and maybe a dip netter on the shock boat as well. So as you can see here, we've got 2 boats like this, a crew of 3 people here, another one somewhere else, 3 more people. You got 3 boats, that means 3 drivings of the equipment to the lake. You've got a crew of 6 to 9 people. I mean, this is like 3 times the gas and manpower required to do most sampling. So we really do want to look and see, are there ways that we can make this more efficient? Because it's fairly costly to get a good low-frequency electrofishing sample. Well, Chris and I looked at the literature, and the most obvious thing to look at in terms of efficiency to us was the sample duration. If you look in the literature, you see samples anywhere from 5 to 15 minutes being used fairly frequently, but nobody's really compared to see, do I get better quality data if I take a longer sample? There are some trade-offs that might come up when you're looking at a shorter sample duration. So all things being equal, we'd kind of like to do a 5-minute sample. You can take 3 of those in the time it takes to do a 15-minute sample, right? The problem is shorter durations will probably bring up fewer fish and therefore probably have higher variability. So you may run into precision problems where you're going to need more replicates anyhow. Maybe just going a little longer would allow you to actually have a smaller overall effort. Then second of all, there's possibly some concern about size bias here. If different size classes of fish are surfacing at different times, perhaps because they're hanging out at different depths in the water column, or just physiologically if they respond differently and surface at different rates, then you're going to get a different picture. If you shorten that sample, you may be getting a subset of the full sizes that are there if you didn't give it long enough for all size classes to eventually surface. So that was specifically what Chris and I wanted to look at. We were working in Oklahoma. They have a 10-minute standardized protocol, and so we're specifically wanting to compare 5 minutes with 10 minutes to see if the quality of the data that we get are similar at those 2 different sampling times. The metrics we'll be looking at are catch per unit effort, both of all fish sizes, and then catch per unit effort of fish over 762 millimeters, which is 30 inches. We then looked at precision of those catch rate statistics using relative standard errors, and then we got 3 ways that we're looking at size structure. We've got PSDs of preferred size fish, and then length frequencies. So for our approach, we're using 3 lakes. The lower left corner here, you'll see the map of Oklahoma. There in north central Oklahoma, the right is a blow-up of that circle area. Caw and Keystone Reservoir were slightly smaller. We used 12 different sampling stations on those lakes. Oologah, which was a little bigger, we used 16. So that across lakes gives us a total of 40 sample locations. At each sample site, we're using 15 pulse per second low frequency. It's from a Smith Root 5.0 GPP. We're standardizing our amp output to get standard power in the water. And then 2 chase boats. There's no dip netter on our shock boat. So here's our shock boat. We just have a driver. And then in the foreground and the background, you see our 2 chase boats, each of which have 2 dip netters. At each site, we sampled for 15 continuous minutes, with fish caught in the first 5 minutes going into 1 live well, fish caught in the second 5 minutes in a second live well. So before I talk about the analysis, I want to talk a little bit about our design options. Chris and I put a lot of thought into what's the best way to approach this, and I kind of want to step you through that thought process so you see why we're doing it the way we're doing it. So the first thing you might think of doing is comparing the first 5 minutes with a full 10-minute sample, because that's kind of the question, right? The problem with that comes pretty obvious when you start thinking about statistics, though. All of our tests assume independence of data. The fish that you catch in the first 5 minutes are all present in the 10-minute sample as well. So there's a huge degree of autocorrelation there that would violate those assumptions. So that's kind of a non-starter. There's just no way to really deal with that well. Second approach that one could use is to take a bunch of independent samples, randomly assign half of them to be 5-minute samples, the other half to be 10-minute samples. This is a solid design. It would work very well. The potential problem with this, as I mentioned, is that you're pretty much hitting one school when you do this, and those schools are somewhat size specific, such that this adds a lot of variability. Any 5-minute sample paired with any 10-minute sample is a different school of fish, and you're going to need a much higher level of replication to overcome the noise that comes from that. So a third approach is the one that we're going to use, where we're comparing the first 5 minutes with the second 5 minutes of a 10-minute sample. That may feel a little weird at first, but if we don't find a statistical difference between the first and second 5-minute intervals, then we know that a full 10-minute sample would be similar to the 5-minute sample, just with twice as many fish. This avoids all of the above problems, and I would argue it's actually the relevant question. When you go and you sample, you're going to turn on the juice and you're going to sit there for at least 5 minutes. The question is, do I have the quality of data I need at this point, or is there something to be gained by going an additional 5? What's in that next 5 minutes, and would it be worth my time to do that? So with that, let's talk about how we analyzed our data. The metrics that I showed you before are mostly going to be analyzed as first 5 versus second 5 using a repeated measures ANOVA. We've got the individual sampling sites that we used nested within lake as the repeated subjects that we measured first 5 and second 5, so 2 measurements at the same spot. And that deals with some of the autocorrelation that would occur just because of repeatedly measuring the same lake or the same site multiple times, and accounts for that lack of independence properly. There are two exceptions to this analysis pattern. The first one is for length frequencies. Obviously, an ANOVA wouldn't work well here. We're using a Kolmogorov-Smirnov test to look at the cumulative distributions on those. And then the real big difference is our relative standard error. So relative standard error is a measure of precision or variation in the sample data. Because we hypothesize that a longer sample with more fish may have lower variation, higher precision, we wanted to actually compare a full 10-minute sample with the first 5 minutes. So this is the one that we actually did do, first 5 versus full 10. And then we used DeMont and Schletke's approach to resampling to estimate the number of samples that would be required to hit a target benchmark on precision of relative standard error equal to 20. All right, so with that, let's get into some results. We caught roughly 2,000 fish that are included in this study. About half of those in the first 5 minutes, about half of those in the second. So it probably won't surprise you that we don't see big differences in catch rates. So on the right here, while we're off the top of the page, that's not good. This graph is total catch per unit effort, all sizes. This graph is just those fish over 30 inches. The black bars on each graph is the first 5-minute interval. The orange bar is the second 5-minute interval. And then we've got our reservoirs across the bottom. What we see for both metrics is that it's variable from system to system as to which one had the higher point estimate in the first 5 or the second 5. None of these are significant differences. So we didn't detect any differences. And again, you know, where one lake is higher, another lake is lower, it really doesn't seem to be any pattern there. If we look at the precision that go with those estimates, let's start with the total catch per unit effort. We had really high precision, very good estimates here. And the number of samples that would be needed to hit that target is actually quite low. We know that we need to be doing about 20 samples just to get good spatial coverage anyhow. For the most part, there's no difference between 5 and 10. There might be something going on here at call. It looked like the 10-minute sample might be slightly better. But again, we're not going to go out and do 3 samples. We're going to be doing 20, so it's really kind of irrelevant, even if that is a real difference there. When we look at the fish over 30 inches and the catch rate of those guys, precision is a whole lot worse. In fact, we're kind of struggling to really do much with that given the data quality that's there. But you still see the same basic pattern. There's no real advantage to one time interval. So we got a little bit better precision at 10 minutes in call, but we actually had better precision in the first 5 minutes in Ulaga. So no strong patterns. I was quite surprised by that a 10-minute sample really didn't guarantee better precision. All right. Let's now look at size structure. First way we'll look at that is with our PSDs. Got regular PSD up top, PSD of preferred size fish down here. Same basic layout as the CPUE graphs. And again, no statistical significance here. We see occasionally one bar is a little higher in one lake, the other one flips over and is in the other. Again, none of those comparisons are statistically different from each other. So similar size distribution coming up, first 5 and second 5. Lastly, we've got our length frequencies. First 5 minutes on the top, second 5 minutes on the bottom, lakes in different columns here. Just looking at them, pretty similar silhouettes. The Kolmogorov-Smirnov did find one difference. It was an Ulaga reservoir over here, but really it's not a meaningful difference. What happened is our mode has a considerably higher percentage of the population in the second 5 than it did in the first 5, and then it falls off a little more rapidly. But again, I would argue that as a manager, looking at those two length frequencies, you're going to be behaving the same way. That's kind of telling you the same thing. I got a lot of young fish, not a lot of big ones. So to wrap this all up, we found that the 5 and the 10-minute samples seem to have pretty similar quality for all of these metrics. The one place we did find statistical significance between them was the length frequency, but you just saw that. I don't think it's really a striking difference. There's not like a true size bias going on. I think it's just sort of random sampling error that drove that pattern. So our conclusion, all things being equal, and things rarely are equal, but all things being equal, a 5-minute sample probably is going to be more efficient for most people. So that would be our overall recommendation. But we need to throw some caveats out with that. The first is, we have catch rates that are around 200 to 550 or so fish per hour. If you've got a system where you're getting consistently lower catch rates, I'd be a little concerned about the precision there, and I'm not sure the results of our study would apply. So keep that in mind. The second is there's no one-size-fits-all pattern for all systems here. And so depending on your sampling objective or your system, you may have different results here. In fact, just saw Zach's presentation, not the one he just did, but the one before that. He compared 5 and 10-minute samples, and he found higher catch rates in the first 5 minutes. I don't know if that's something to do with the depth of the fish. It is a shallower system. He's also a lot more riverine than our reservoirs were. But whatever that is, again, your mileage may vary. So, cautiously, we're recommending that a 5-minute sample may be more efficient for you, but you probably need to evaluate your system and your sampling objectives before lock, stock, and barrel taking that. If I have time, I'd be happy to take questions.
We have time.
Jason?
Andy, so when the electrofishing boat is stationary during the entire 5-10-minute sample?
Yeah, I really glossed over the methods there. It's the same methods we used in Bodine and Shoup 2010, but we start stationary. I can't remember the exact time. I think it's like 3 minutes. If fish surface, we start moving towards the fish, trying to get to that school. If nothing surfaces in 3 minutes, we take a meandering approach along the transect that's been randomly assigned to it.
Okay. The reason I asked in your next to last bullet point there is deals with what we had, situation we have, because we've got
Low catch rates?
yeah, we've got some of our reservoirs that we've done, and we've had nothing surface in 5 minutes, and then you start seeing some.
And that is definitely, I mean, obviously if you've got no fish, zeros are a real problem. And I know Zach had a zero inflated data set. We get occasional zeros, but our catch rates are much more consistent. First minute, minute and a half is kind of dead, but it makes up for it real quickly in minutes 3, 4, 5. Other questions?
One thing I'm struggling with is duration and whether 5 minutes is too long in some situations.
It could be.
Because we hit that magic minute mark, and it's clockwork for those things.
What's coming is coming, huh?
Give or take 5 seconds.
Yeah.
And you hit on it that these schools are size specific, which we see, and the more schools you can hit, the better sample you're going to get. And if you do shorter stations, you get more. I guess what I'm asking is there any consideration of looking at shorter stations than 5 minutes?
I know a lot of flathead papers have used a 3-minute sample. That's a lot more efficient if it actually works. I'd be hesitant to say anything there, Ben, because I haven't tried it. But it's not hard to do what we did. Just an extra live well is all it takes while you're doing routine sampling, and after you've done a bunch of it, analyze those data. I do think that's the goal, is make sure you're getting quality data, but shorter is better if it's not getting you anything more to go longer. So you got to be cautious. The precision is the real thing that I would be worried about, and the frequency of zeros, as Jason was mentioning too. But certainly I wouldn't hesitate to recommend looking into that.
More questions? Okay, thanks.